Problem 2-21. Plot each pair of points and find the distance between them. Give answers in both square root form and as decimal approximations. Letter A, 3, -6, and the point -2, 5. So for this one, I've already taken the time here to plot the 2 points. This is my -2, 5, and this is my point 3, -6. Now, if we want to find the distance between them, that means we're trying to find the distance of this segment here. There's several approaches we could take. We could use either the distance formula, or we could use the Pythagorean theorem. Now, both of these methods are really honestly the same thing. You're just looking at them from a couple different perspectives there, or you may use them a little bit differently in different situations, but really it's the same exact thing. And I'll go ahead and give you those. Remember, the distance formula is going to be the distance equals the square root of the difference between the x coordinates of 2 points and squared plus the difference between the y coordinates of 2 different points squared. And if sure, you could work through this backwards and you could figure out here this is the same thing as doing your Pythagorean theorem, which is a squared plus b squared equals c squared. So we've got this triangle here, and if I wanted to use the Pythagorean theorem, I could look at it as the distance. What's our distance between our x coordinates? Well, that's going to make a horizontal line. That doesn't look very horizontal, I apologize. And then our vertical distance between the points here, when we draw that on here, you'll see that this is going to make a right triangle. In which case, we know the distance from -2 to +3 is going to be 5 units. And the distance from -6 all the way up to 5 is going to be 11 units. So if we're trying to figure out the hypotenuse here, we could say that's going to be side C. I almost wrote squared there, but that is not squared. So if I want to use Pythagorean theorem here for this, I'm going to say 5 squared plus 11 squared should equal c squared. Let's see here. 5 squared is going to be 25 plus 11 squared is going to be 121. That should equal my c squared, so that is going to be 146 equals c squared. And we'll take the square root of both sides. And normally, remember, the square root of c squared would be the absolute value of c. But we don't need absolute value here because we're talking about distances, and so it can't be a negative distance. So we're going to have c is going to equal the square root of 146. So this is our square root form. Okay, so we have right now the square root of 146. Now, if we want to come up with our decimal approximation, just pull out your calculator and do second square root 146. Enter. We get about 12.08. So we'll put that in it. That's approximately 12.08. All right. Now, if we wanted to use the distance formula, you just have to make sure you identify what your points are and use those here. So I'm going to make this point number 1 and make this point number 2. I'm going to show you how to do it with this one as well. So we're going to say the distance is going to equal the square root. Now we're going to do the second x coordinate minus the first x coordinate. So -2 minus 3 and we're going to square that, plus, if we started here with -2, then we have to start with this 5. 5 minus -6, which is the same thing as 5 plus 6. And we're going to square that. -2 minus 3 is going to end up being -5 squared, plus 5 plus 6 is 11, so we have 11 squared. So we're really looking at 25 plus 121, which is what you saw over here. Except it's all under the radical already, so we get the square root of 146. So you see this gets us the exact same answer using the distance formula versus the Pythagorean theorem. Okay, let's look at B now. Now you can choose whichever method you feel more comfortable with for this problem. We're looking at the point 5, -8, and the point -3, 1. So as I plot them first, I realize my coordinate plane's not quite big enough, but I'm going to just draw it in and kind of estimate down here where -8 is going to be. So it's somewhere right down here. And then I've got the point -3, 1. So I'm going to go back 1, 2, 3, and up 1. So I have here, I'll try to draw in a little bit of a line here. We're trying to find this distance, and that's not going to work. We'll just have to cheat here. That'll be easier. Bam, just like that. So if you want, you can do the Pythagorean theorem if you're more comfortable with that process, or you can do the distance formula. Either way, you'll see here what you're looking at is another right triangle. This side here goes from +5 to -3, which is a total distance of 8. And this distance goes from +1 all the way down to -8, so that would be a distance of 9. So you could call that C if you're going to do Pythagorean theorem. I would say 8 squared plus 9 squared should equal C squared. So I should have, oops, jumping the gun there, it's not 7. 8 squared is going to be 64. 9 squared is 81, so I have 64 plus 81 equals C squared. So 60 plus 80 is 140, plus 5 would be 145, equals C squared. And then to get it by itself again, here we could take the square root like we did on the problem before, and we get the square root of 145 equals C, because we can't have a negative in this case. So our radical form, or square root form, is the square root of 145. And the decimal approximation should be pretty close to what we have up here. Let's just go ahead and do it on the calculator to save time. Second square root, 145. Enter. You get about 12.04. So that's letter B. Letter C says we're supposed to do this for 0, 5, and 5, 0. So I'm going to kind of be creative and just kind of add this one in on the graphs over here. So the point 0, 5, which is right up here, and the point 5, 0, which is right there. So we're trying to find that distance between them. So with this one, use Pythagorean theorem or the distance formula, it's up to you. We know this distance is 5, we know that this distance is 5. So we kind of have an isosceles right triangle. So we're going to have 5 squared plus 5 squared should give us our C squared, or whatever C is going to be. So let's just kind of squeeze this one in. Actually, let's move this down. So we've got our 0.50 and our 0.05. So we're going to do a squared plus b squared equals c squared. So we have 5 squared plus 5 squared equals c squared. So we have 25 plus 25 equals c squared, which gives us 50 equaling c squared. We take our square root and we'll end up with the square root of 50 is equal to c. So looking at square root of 50 is what our distance between those points are going to be. Now it says letter D, write the distance you found in part C in simplified square root form. Oh, you know what? I forgot to get my decimal approximation here, so I need to do that real quick as well. Let's just go ahead here and pull out the calculator. We'll do second square root 50. Enter. That's about 7.07. And now we can do that last part that it was asking for. So once again, it says write the distance we found in part C in simplified square root form. To simplify something that's in square root form here, what we have to look at is this. If you have the square root of A times the square root of B, it's going to give you the same thing as the square root of the product AB. If you think about it, the square root of 4 times the square root of 9 should give us the same thing as the square root of 4 times 9. Well, 4 times 9 is 36. So the square root of 36 is 6. Let's see here now. Square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6, so we know that this rule, this property holds true. So we're going to be looking for perfect square factors. Sorry about the handwriting, it gets tough on here sometimes. So I'm going to take the square root of 50 is the same thing as saying 25 times 2. 50, same thing as 25 times 2, in which case we can take this, and using this property here, we can say this is the same thing as the square root of 25 times the square root of 2. And when you do that, the square root of 25, we can simplify more. We get 5 times the square root of 2, which is, in the end, is going to be 5 radical 2, or 5 square root of 2. Right now, there are no more perfect square factors inside of 2 besides 1, so we know we're simplified. This is problem 2-21 from the homework. If you have questions, please make sure you ask your teacher. Otherwise, thanks for watching. I hope that helped.